for Rice Research, Hyderabad. I want to read out a small biodata. Dr. Santosh Rathod is a scientist in agricultural statistics, working at ICR, Indian Institute of Rice Research, Hyderabad. He has received PhD in agricultural statistics from Banaras Hindu University during the year 2017. Dr. Santosh joined ARS in the year 2014 and served at IISRI, New Delhi for 4 years. Then later he joined in Indian Institute of Rice Research during the year 2018. His research expertise includes statistical modeling of biological data, spatio-temporal time series modeling, artificial intelligence in time series, and agricultural data. He has several papers in reputed journals in the area of statistical modeling and artificial intelligence. He is the recipient of G.R. Seth Memorial Young Scientist Award from the Indian Society of Agricultural Statistics in the year 2017 and Best Young Scientist Award by ICAR, Indian Institute of Rice Research, Hyderabad during the year. So with this small introduction about our today's speaker, Dr. Santosh Rathod, who is going to deliver a topic on forecasting techniques, which is very, very important. And for this session, I welcome the great statistician, Dr. CSK Umashankar Garu, who is a former registrar, and also Dr. Muniswamy Garu, the head of the department and professor, Andhra University, and all the participants from Andhra University and throughout India. It is a national workshop. So with these few remarks,
sir.
Yes, sir. Anything to say? Anything to say?
Nothing, sir. You can start, sir. Umashankar sir is also with me.
Umashankar sir, you want to say something?
No, sir. So proceed.
Yeah. Okay.
Yes.
Santosh ji, so it is 1.5 hour time, and what extent you can complete the forecasting. As we know, it is a very, very big topic given to you, including the hybrid models and all. But because these are the different heterogeneous group, starting from statistics to agriculture sciences and all, that is why my request is you please go slowly, and what extent we can cover, you can cover, sir. And it is open to you all, and I am welcoming you all once again. And first of all, I want to thank you, sir, for accepting our request within a short notice. And moreover, you changed your session from evening to morning also. That also for that, I once again thankful to you, sir. And with these few remarks, I welcome Dr. Santosh Rathod ji to start our session.
Thank you, sir, for your kind words, and thank you very much for giving me an opportunity to present my work here. And without much delay, I will share my screen, and already the R code and the data related to this session has been I mailed to you, sir, so you can share with the participants. And I will start with the theory. So I will share my screen. My screen is visible to you, sir?
Yes, sir. Yes, visible.
Yeah. Okay. Good morning, all. The today's topic assigned to me is forecasting techniques. But I spoke to him and said that most of the forecasting techniques highly heterogeneous and non-linear in nature. So I thought I will deliver a class on artificial intelligence and their application in forecasting techniques in agricultural data. So I kept the name of the talk as application of artificial intelligence-based models in time series data. So in this class, I am going to cover some of the preliminaries of time series analysis and how this forecasting will be done. And then how the time series, what are the steps in time series model building, and then what are different classical models of
just your voice is a little bit low.
Yeah,
Please increase the volume.
Yeah. Okay, sir.
Yeah. Okay. Thank you.
Yeah. In this, I'm going to cover the preliminaries, then how the time series model will be built, then what are the different time series classical models. Pardon, sir? Okay. And then what are different machine learning time series models? Then how these hybrid models will be built, under what situation we go for the hybrid model. Please mute yourself. And then with some examples, and then I will conclude with some suggested readings. Okay. So here, when you come to the time series, then we'll say what are the time series. Then before the time series, you say what is the data. Data is anything, the information which is collected in the form of numerical numbers, and the data may be generated either from the experiments, survey, or published sources. So here, mostly in time series analysis, we take the data from the published sources. There are many sources or agencies which collect the primary data and they publish. So we call them it as a secondary data. And mostly we use secondary data for our time series analysis. For example, economics and statistics, they publish area yield and production data. So those data will be used as our time series data, like temperature data, rainfall data, or other data. Time series are the observations which are collected over the period of time. Suppose say I have a temperature time series, so I collect the data of temperature today, tomorrow, day after tomorrow, and like that. So this data they are recorded over the period of time, either maybe equal period of time interval or maybe an unequal interval. So these kind of data we call them as a time series data. So time will be dependent here, time series. So then we have spatial data. The next category is spatial data, where we collect the for single point time we collect the data over different spaces. Suppose I collect the temperature of today over Hyderabad, over Kernel, and over like the different places. So this data, the spaces, we call them as a spatial data. Sometimes we have data both space and time. I collect the temperature data of let us say 7 or 8 places simultaneously. So this data we call them as a spatial temporal data, where the relations will be exist between both space and time. So these are all the different kind of data we will use in a time series. And then usually this in time series, sometimes the time series will be dependent on the only 1 or 2 or recent periods. So those periods can be, those data can be modeled using the moving averages or exponential smoothing. So there are though these are very basic techniques in time series forecasting, like single moving average, for double moving average, simple exponential, double exponential, and triple exponential smoothing. These 5 models, basic models, can be used pattern present in the data, whether they are linear or quadratic, or whether they have constant. Based on the nature of the data, we use this moving averages and exponential smoothing. But one thing we have to remember is this moving averages and exponential smoothing will be used only when you have recent dependency in the data set, like 1 or 2 lags only. Let us say I want to forecast tomorrow's temperature, I use today's data only, so today's dependency only. So this kind of data can be modeled using moving averages and exponential smoothing. And then next comes the trend, the trend in most of the agricultural weather parameters, and then your climatic variables, rainfall, those things can be studied using the linear trend, then monotonic trend. There are tests called Mann-Kendall test, a local regression based test. These all tests can be used to identify in the data set. Why I am explaining these components is time series contains 4 components, like your it has your trend, it has a cyclic variation, it has irregular variation, and these kind of and it has a seasonality. This can be modeled or decomposed using this moving. So when I say time series, the time series data should be autocorrelated in nature. It means today's temperature should be dependent on yesterday's temperature. If there is no dependency, then we go for the regression technique. So we will not go for the time series technique. So the basic requirement for any time series analysis is the data should be autocorrelated in nature. Auto means self-correlation. Today's temperature should be dependent on yesterday's temperature, day before yesterday's temperature. This year's yield should be dependent on the last year's yield. So this kind of data only modeled using the time series analysis. Otherwise, we should go for the regression analysis. This, for any forecaster, this should be the basic fundamental. It should be like, it should satisfy the property, then only you can go for the forecasting techniques. And to test the whether series is autocorrelated or not, we have the test called box PS test. In our package we have box test. So if it comes significant, then we can say yes, the data under consideration is autocorrelated. Now we can go for the time series modeling. Then another, suppose you have 50 years data, you divide the data into 10 parts. Then each 10 parts, if you check mean and variance of that particular part should be constant over the different parts. So this we call it as stationary process. When you divide the series into different parts, that mean and variance should be constant over a period of time. So this can be tested using the ADF test, that is augmented diffuser test. And if it becomes significant, then you can say yes, the data under consideration is stationary. Then we can move further for the modeling. Suppose if the data is not stationary, then what we can do is we go for the differencing, first order differencing, second order differencing. Then then the series will become stationary, and so we can go for the modeling. For example, actually the model is ARMA. Then if you go for the different one differencing, then the model will become ARIMA model. Okay. The most popular model in time series analysis is ARIMA model. That is, we popularly call it as a Box-Jenkinson model. And Box-Jenkinson are the people who proposed this model. And is the most popular model in univariate time series modeling, often referred as a mixed model because it has a process of autoregression and moving average. Moving average means if you, for example, a difference between the predicted series, that error is the that component, that moving average is dependent on the error will be dependent. So this we call it as a moving average. So this we have the model here. The first part is autoregressive part up to the t minus p, and the next part is this is a moving average part. Will be represented by your autoregressive order and q will be represented by your moving average order. So theta will be your moving average parameter and phi is your autoregressive parameter. So to build the ARIMA model, we have 5 steps. The first step, as I said, autocorrelation should be there. To satisfy that, we have box pierce test, and then the second property is stationarity. The data must be stationarity in ARIMA process. So if it is not stationary, then we can go for the differencing, and then we can make the series into stationary. Okay, once these two properties are satisfied, then what we do is we identify the orders of the ARIMA model. As I was saying, P and Q represent the autoregressive and moving average lag orders. So if you see here in this, if you see here ACF and PACF, ACF means autocorrelation function and PACF is partial autocorrelation function. These two functions are used to identify the autoregressive and moving average orders. Here ACF is used to identify the moving average order and PACF is used to identify the your autoregressive order. For example, pardon, any question? Okay. And if you see here, in this graph, you find only one significant lag here. It is going out of the blue line. That we can say yes, there may be a two autoregressive order. And here there are one significant spike. These are the zeroth lag, and here almost like only one line is touching to the ACF. Then you can say one moving average lag. So like that you can identify, but the best procedure is based on the lowest AAC, BAC values only. We have to identify the orders. Like if wherever, suppose you try with 0, 1, 2, 1, 0, 1, 1, 0, 2, 2, 0, 1. You try with the different model combinations, and wherever you are getting the lowest AIC, BIC values, that order you can consider as a final order. Any question? Once the model orders are identified, then we go for estimation. The models will be estimated using either ordinary least square or using the maximum likelihood estimation methods. And once the models are estimated, then we go for the diagnostic checkings. So diagnostic checking means here, as I was saying, residuals, the difference between the actual and predicted values. And this residual should follow the normal distributions. If they do not follow the normal distribution, then for again different lag orders, and again we refit the model, and whenever we get satisfied model orders by proper diagnostic checking of the residuals which follow the normal distribution, then we can say yes, this model is final, and now we can go for the forecasting. So these 5 are the basic steps in time series modeling. This is not only true with the ARIMA model. So for all the time series, first we check the autocorrelation, whether the data is correlated or not. If it is autocorrelated, then only we go for time series modeling. Then we see the stationarity, and by ADF test, if data is stationary, we model orders by AIC, BIC values. So once the model order is identified, then we go for the estimation of the model using OLS and ML. Once the model is estimated, then we go for the residual diagnostic checking. The residual should be normally distributed. Then we go for the forecasting. Okay, is it clear up to this? Or am I?
Yes, sir.
Okay, then we go for next. Yes, I was saying, suppose when the data has a short memory, like it depends only on up to 1 week or 2 days or 3 days, then you can go for linear ARIMA model. But sometimes what happens, the today's price data may be dependent on three months, 4 months, or 5 months, or 1 year, 2 year back data. So those kind of data we call them as a long memory data. So the model has long memory. For example, this forestry data where tree rings will be dependent on 100 years or 200 years tree rings. So such kind of data we cannot be modeled using the ARIMA model. So that model we can model, those kind of data can be modeled using the ARIFIMA model. ARIFIMA means F means fractional. So model is same as your ARIMA only, but here the fractional term will be added. It means your difference term will be fractionally made. Like it may not be a like one integer 1 2 3 third difference, but it will be like a fractionally differentiated. So this model, this kind of data can be modeled using the long memory ARPIMA model. So and this will be highly useful in the this agriculture commodity prices, where the price, sometimes the prices will be dependent on the 3 months, 4 months, or it may be the 6 months, 7 months price. So under such condition, you can go for the ARPIMA model, not ARIMA model. So how we come to know like whether it is a long memory or not? The test is there to long memory. So for that we have rescaled range test, RS test, and by RS test, if the D ranges between 0 to 0.5, then we can say yes, the series is long memory. Now we should go for the ARFIMA model and not ARIMA model. And when you plot the ACF plot also, you will see the exponential decaying of the series. Like the ACF, you have slow decaying. Up to, you see in here, up to 200 lakh, the series is slowly decaying. So such series you can call them as a long memory series. So again, the model building procedure will be remain same. The only difference is you have the D is ranges between 0 to 0.5. Again, we check the autocorrelation test. Then we go for the long memory detection, R by S test, stationarity, model identification in AIC, BIC, estimation, maximum likelihood. And one addition to this is we have GPH estimator here. So GPH estimator most of the time will called as a robust estimator for long memory time series. And these are all estimators, and these are all available in the R package. So that automatically give you the estimation. And then we have diagnostic checking by box-based test, and once it is satisfied, then we can go for the forecasting. So now here you need to remember, if the data is long memory, then we need to go for RPMO model and not the ARIMA model. Okay. So next we have count data. Your insect pest. Suppose some insect pest, for example, gallmids. Gallmids is a rice pest, and you install a light trap in the field, and daily you count the data. You don't have fractional number here. You count the data. So daily you go to the field and collect the data, and data will be count. And sometimes these counts also be auto-correlated. So today's pest population will be dependent on yesterday's population, day before yesterday's, 1 week, 2 weeks, like that. So most of this entomological pest population, they are all the count data, and they are all most of the time will be auto-correlated in nature. But what we'll do, since some people might be not knowing or due to the unavailability of computation techniques, we convert the data forcefully into the square root transformation, and we do the that normal ARIMA model, but that will not give you a proper result. There are discussions and paper published in a good in a journal like a Journal of Agriculture and Biological, that statistics, where one group of team, they proved that if you forcefully transform the count data to the normal distribution, and then also we do the ARIMA model, that result will not lead a good lead to a robust non-transformed data using generalized linear model, which follows your negative binomial distribution and Poisson distribution. So we should be very careful while using the model. If the data under consideration is count in nature, we should go for the Ingard's model or Poisson model or your negative binomial model. So in this recently we published one paper where we taken the Galmich data and we did the count time series modeling. For the count time series modeling, generally the count time series follows the generalized linear model, and based on the nature of the data, whether the data is Poisson distributed or negative binomial distributed, and you have to choose the right model in the count time series. So here you need to remember that when the data under consideration is count in nature, then we should go for the count time series model and not the classical time series models. Okay. And then we have intervention time series model. We call them as a time series intervention model. Sometimes what happens, your data, you have the price data, but due to some sudden changes of the government, sudden change in the government policy or some calamities, the time series will be disturbed. So under such condition, we cannot model using your ARIMA model. So we have to for the intervention model. For example, in 2020 March, the government has announced a lockdown due to severe increase in the COVID cases, and most of the agricultural commodities supply has been disturbed, and because of this, the price has been increased. So this kind of intervention or impact you cannot assess using the class. These kind of things can be estimated using your ARIMA intervention model. And in ARIMA intervention, we can estimate the linear pattern only. So what we have recently developed a model where we use artificial neural network AI-based intervention model, where we added your interventions exogenous variable in the model, and we developed the model to estimate the effect of COVID-19 in tomato price and supply in some of the major markets of Telangana. So we have to remember here, whenever the data under consideration has some sudden impact or this external factors intervention in the time series, we should go. Okay. And then comes as I was saying, the spatio-temporal time series. Sometimes the data we have over both the period of over space and time. Though under such condition, we should go for the spatio-temporal time series models. For example, you say, for example, consider temperature of this location. I am presently I am in Rajendra Nagar. So temperature of Rajendra Nagar depends on, sometimes it depends on the neighboring place temperature. So what we do in ARIMA model is we will not consider the neighboring place temperature. We consider only Rajendra Nagar temperature, and we forecast them using ARIMA or any time series or AI based model. But sometimes what happens when you neighbors are also have the impact on the particular data, then we should consider the neighboring effects also. That can be considered using your special. Suppose their boundaries touched that two location, then you can assign the weight 0.5, 0.5 to the both the spaces, and you can consider them in the model. And we have many papers in spatio-temporal time series. If anyone is interested, we can further discuss those. Again, in this spatio-temporal time series also, the model building steps are same, where first we see whether the earlier what we used to do is we used to check whether the data is autocorrelated or not. Here we see whether the data is spatio-temporal correlation is there or not. So to test that, we have the multivariate box space test. Once the data under consideration is correlated both space and time, then we can go for this kind of model. Then again, stationarity. Then here one step we'll add the building of special weight matrix. As I was saying, that how we add the dependency in the data set, that can be added using your uniform weight matrix. So the different kind of weight matrices are available. Uniform weight matrix, Euclidean distance, KNN weights, fuzzy logic, correlated weights. So these all can be added in the model in terms of special weight matrix. Again, similarly, as in ARIMA, we used to use ACF and PACF. Here we use STACF and STPAC, space-time autocorrelation function and space-time partial autocorrelation function to identify models. And then we estimate the model using maximum likelihood estimation. And here, for the first time, we have proposed and developed genetic algorithm and optimization based estimation methods for spatial temporal models also. And we have diagnostic checking. The whatever model you build, time series model, that the residual should be normally distributed. Once it is normally distributed, then we can go for the forecasting. Okay. So these are all about different time series components or different times. We can call it as a different branches of time series whenever the nature choose the right model. Okay, this is about the how we choose the weight. So we have assigned, this is one data set. We have suppose you say for the first location the second and eighth location are correlated, so I will assign 0.5 and 0.5 to the first and eighth location. Like that I assign the weight to the neighboring series in case of spatiotemporal model. This is all about the classical time series model. So here, if anybody has any queries in understanding the classical time series, they can ask me for 1 or 2 questions. Then we move for the this machine learning based models. Any queries? Okay. Next comes the AI-based techniques. AI is the artificial intelligence, is a field of science that creates machines or devices that can mimic the intelligent of human intelligence or intelligent behaviors of the human brain. So, for example, medical diagnosis, electronic trading, robot control, and remote sensing. These are all the examples of artificial intelligence application. Nowadays, in agriculture, also, like many examples are there that AI-based irrigation control and AI-based drone spraying. That many applications of these are all about the artificial intelligence applications. And then we have machine learning. Is a type of machine learning is a type of AI that provides computers with the ability to learn without being programmed every time. Okay, so these machine learning techniques, that they are the data driven techniques rather than the distribution based techniques. So Arthur Samuel, we call him as a pioneer in the machine computer science that gives a computer's ability to learn without being programmed every time. So this definition has been given by Arthur Samuel, and here for the first time he has developed the program for the self-learning program. He has developed a game that is a checkers learn game. The every time whatever the learning or experience outcome will be dependent on the earlier experience which he learned while playing the game. So ML is a subset of AI technique which uses statistical methods to enable the machine to So machine learning is a subset of artificial intelligence techniques which use statistical learning algorithms to improve its performance. And that means it combines the programming like algorithm plus probability and statistics to make the learning better. So here is the difference between your AI and machine learning. So artificial intelligence is your output and machine learning is your engine, right? This difference we should know about artificial intelligence and your machine learning. And there are 3 kind of learning: supervised learning, unsupervised learning, and reinforcement learning. Sometimes supervised learning, it is a kind of teacher student learning or classroom learning where the teacher will be, suppose I am teaching you here and you are learning. This kind of learning we'll call it as a supervised learning, where you give input data as well as the target data. So these kind of techniques we learning, we call it as a supervised learning. And the next class is unsupervised learning, where no target labels are given and we'll do the self study and we learn ourselves. So these kind of models are called as unsupervised models. And then we have mixed category, that is reinforcement learning, where some part will study from the teachers and some part we do the self study and will build the model. So these 3 types of models are available in in most of the class of models. So we can use based on our what kind of input we have with us. Okay, and again, if you broadly, if you classify the machine learning into two classes, that is machine learning sometimes we use for classification problems, and machine learning we can use for the regression problem also. And classification means here we have two or more classes, and we don't know the nature class members, then we can divide them using the classification techniques. And pattern recognition also can sometimes they make it a different class, or sometimes it can be combined into classification. And regression, that our time series and regression models comes under the regression class of the machine learning models. Okay, so these are different models like linear, polynomial, non-linear model can comes under the regression class of machine learning. So you have to understand here, machine learning or artificial intelligence in time series data falls under the regression class of machine learning. Okay. As I was saying, like artificial intelligence based techniques, they have come from the inspiration from the human brain. So based on the biological neural network, the human brain, the ANN has been evolved. So the structure is similar to our human brain, and from that it has made it as a they made it an artificial neural network. And I will show you in the next slide like how it is similar to our human brain. And it is estimated that brain is composed of around 10 to the power 11 neurons that works in a parallel, since the processing done by neurons and the memory captured by the synapses are distributed together over the network. So our brain has the capacity of 10 to the power 11 neurons. So our brain is much powerful than our the computers what we have with us. Okay, this is about the like similarity with the human brain. If you see here, the major components of each neuron is they have dendrites, and dendrites we call them as the inputs, and then we have cell body. The cell body we call it as a hidden layer or your processing part, where inputs will come through your dendrites, and the information will be processed in our human brain in a cell body, and then information terminals. So these three components are similar in case of artificial neural network, where we have input layer, hidden layer, and output layer. Similarly, we have here dendrites, cell body, and axon terminals. So the outputs which came from the axon terminals can be used as input in again the different neuron as in case of as a dendrites. Okay. So if you see here, the Maclo and Pitt model is the first artificial intelligence model which is used to which they call them as a threshold logic model. Earlier it has two parts, the input parts and output part, and then the model will be combined and then it will give the output. I will explain it with the example. For example, I would, yeah. For example, I want to make a decision about whether to watch TV or not today. So I have different options with me. So like today, whether I have to watch the TV or not. So I have the option like yes, if I will watch the match if IPL is on. Okay, so I will watch the TV if IPL is on. Okay, and the second possibility could be I will watch the I will watch the TV if TV I care less about the practice match. If it is a real match, then only I will watch the TV today. So this is my second option. And my third option is I will watch the IPL or the TV, provided if MI is playing. So since I am a fan of the MI, so I will decide whether if Mumbai Indians is playing, then only I will watch the TV today. So these are all my different chances. Chances are parts of the decision making. So I will assign them each weight, whether 0 or 1, and I will later what I will do, I will combine the weight. I will combine this all the decisions, and if my decision is, I will fix the threshold theta. If my sum is coming more than the theta, then only I will make a decision. Yes, if the theta is crossing 2, then I will watch the TV. Otherwise, I will not watch the TV. This is how the artificial intelligence works. It does not have any distribution effect. It does not assume any data. It totally depends on our the learning pattern and decision of the or input decision or decision of the modeler. So like this, the model has evolved as a macro and pitch model. Later, what they did in the same model, they have added the bias term. Bias term, they called this model as Perceptron model. So they added the beta here, small b, and this small b is small. Suppose my daughter is not feeling well, then I will give the weight to the b. Then I will not.
డైలీ ఎలా ఉంటుంది సార్ ట్రైన్
Please mute yourself.
అంతే అడుగు ఒకసారి మరి లాస్ట్ 10 minutes
Okay. Yeah. And I will add the
ఇది ఇంటర్చేంజ్ చేసాం
Krishna, mute yourself.
yeah. I will add the bias term to the model. Then this model I will call it as a Perceptron model. So bias term, suppose my daughter is not feeling well, then I will not watch the match because that is my priority. So this kind of intervention can be done in terms of bias term. And as I was saying, network has 3 layers: input layer, hidden output layer. Please mute it. Okay. So input layer, hidden layer, output layer. In input layer, we provide the data, and hidden layer, the data will be processed, and the hidden layer has activation functions too. And this activation function will help us give the relationship to the data, and then we have the output layer. Okay. So yeah, and we you might be heard that deep nowadays simple this deep learning DL also, deep learning neural network. As I was saying, we have hidden layers, and if you have more than one hidden layer in the neural network, then that kind of network we call it as a deep neural network. So or DL, deep learning based model. So if you see here orange color, we have 1, 2, 3, 4 layers. So here our model will be a deep learning model. Okay. So in each deep learning model, you can apply different activation functions also. As I was saying, activation function, the mapping, the activation function will be present in the hidden layer, and which makes the mapping between inputs and the hidden layer in artificial neural network is determined by activation functions. And this kind of activation function will help us to exactly give the relationship between the inputs and your hidden layers. So here there are different kind of activation function. Identity activation function. Suppose your data is linear in nature, then we can go for identity activation function. If your data is sigmoidal, like count data, then you can go for the sigmoidal activation function. If your data is highly heterogeneous in nature, then you can go for tanh, arctine, and sinusoidal sinus activation function. If your data is normal in nature, then you can go for Gaussian activation function. So activation function is a very important part of neural network building, where it can be used to process your data onto the network. And as I was saying, in case of time series model, we have maximum likelihood estimation method. Like in case of artificial intelligence or artificial neural network, we have multiple layer perceptron model. In case of MLP models, we have algorithm called backpropagation algorithm. This we call it the king algorithm in case of artificial neural network, and then it will give us
last 10 minutes
last 10 minutes. Like I have to stop my presentation within 10 minutes.
No, sir. No. It is up to 1 o'clock. You please continue.
Okay, sir. One can this Umsi Krishna, you can mute yourself because again and again. Yeah. See, this backpropagation algorithm is the king algorithm which is used in case of neural network. In time series, most of the cases we use the MLP. How it will start is, suppose we have the weight x here, and it will become like the output here xj, and it will be computed using your input layer input vector ya and your weight wij. then what it will do, it will calculate the desired output, that is your y hat. And once the y hat is computed, then it will take the error component, that is actual, it is a difference between the actual and your desired, that is your output, and it will take the half of the summation of yi minus dj, and it will take it as e, and it will it will do the differentiation of first order and second order differentiation. If the second order differentiation is coming minimum, then it will assign the weight between 0 to 1, and this step will repeat every time for each loop, and the weight will be given to the neural network, and then again it will calculate the desired output for the next iteration. So if you are very much interested like how the neural network will work and their algorithm and structure, then you can go through this paper. This paper is published in Nature Communication. But nowadays, most of the software they will give the output directly. So most of the people they don't bother about the algorithm and all. If you are still interested, you can go through this paper. And as like how the artificial neural network for the time series data can be built is, first we go for the box Jenkinson test, where your data should be autocorrelated in nature, and there is one more test will add, that is PX test. If the data under consideration is non-linear in nature, because when your data will be in linear in nature, then your ordinary ARIMA model will be satisfied. Sometimes data under consideration is highly heterogeneous and non-linear in nature, then we can go for the neural network. To confirm that, we have the test called BDS test. If the BDS test comes significant, then we can say yes, the data is non-linear. Now we can go for the BDS test. So once the data is non-linearity, then what we will do in case of neural network, we divide the data into training part and testing part. So as I was saying, any time series model building has two parts, three parts in fact, model building, testing, and your validation part. So broadly in time series, since we will not be having the feature data, so we will divide into training data and testing data. So generally we divide them into the 90 to 10. Suppose I have 100 observations, I divide them into 90 for the model building and 10 observation for my testing purpose. So once the data is divided, then we go for the normalization, linear transformation, anything is required for the data. Otherwise, you can provide the data directly to the input layer. Once the data is provided to the input layer, then model is built. Then we have to tune the model by different hidden layers, different. We have the. Can you please mute yourself? I'm getting disturbed because. And yeah. This artificial neural network model we build based on the different user-defined parameters like your number of input, number of lags. Sir, Srinivas sir, can you please ask them to mute, sir?
What, sir?
Someone is speaking, sir. I am unable to. The voice is disturbed.
Yeah. Okay. I will take care. Thank you, sir.
Last 5 minutes.
Okay.
Varaprasad, I think somebody. Okay, sir. We'll take care.
Krishna. Srinivas, it is Vamsi Krishna. Somebody.
Yeah. Yes. Once the model is once the data is given to the neural network, then we choose the optimum number of lags and optimum suitable hidden layers, suitable hidden nodes, and then this will be done every time, and we'll check the performance of the model in terms of quantitative measures of prediction performance, in terms of RMSE, in terms of mean absolute percentage errors also. Sometimes if you have the zeros in your input data, then the MAP will not help you. Then under such condition, we should go for root mean square error, and this can help us to see the different which model has performed better. And if the model under consideration has more RMS, then again we can change the parameters of the neural network and we can rebuild the model. And then there is one more test, dibold merino test. If you want to see, suppose RMSE of one model is 10.8 and RMSE of another model is 10.7, then it is very difficult for us to judge which model is better. Whether to see the significance performance of the model, we have the DM test, dibold merino test. This will help us to identify the significant performance among the different models. And the next artificial intelligence model is support vector machine, and the support vector machine will be different. Is different from the neural network, where, as I was saying initially, where we have input layer and target layers. Under such condition, we should go for the support vector regression because it is a supervised learning and it is basically used for classifying. Suppose you can see here, I can classify this the bold dots and the unbold dots using different ways here, different classifiers. But if my classifier has the margin, then I can classify them properly. Misclassification. So support vector machine will mainly help us to thicken the margin, and where it will help us to classify the classes accurately. So the basic idea in support vector machine is it will transform the input data into the original feature space, and the feature space will be made into linear, and it will do the classification. So for example, if you see here, I have the quadratic space here, and this space can be transformed into a linear space by increasing the number of observations or number of variables by adding the extra variables by ourselves, and these variables we call it as a support vectors, and we can classify them in a linear fashion. So by using, if you see here, this, yes. And in case of linear discriminant function, what we do is, if WH plus beta is coming more than 0, then we divide them into one class, and if it is coming less than 0, we divide them into a different class. But sometimes when you have more complex situations, where if suppose, for example, you have x1 and x2 in a quadratic space, your combination will become like you have 6 variables. So what we will do is, we will this quadratic discriminator function can be transformed into a linear discriminator function by z1 by adding the different variables, like x1 will give to the z1, then x1 square to the z2, x3 to the z4. Like that we divide and we make them into a linear. But sometimes what happens, we have the more complex data sets or more high number of data sets, then it will become m cube m to the power n, then the transform space will become high and you cannot classify your model properly and your observation properly. So to overcome that, we have the optimization problems. Like you can go for the optimization, linear programming, you can optimize your class thickness of the classifier and you can divide them properly. A linear classifier relies on the cross vectors, and this we call the kernel trick, and this kernel trick is a activation function in case of. Can you please mute?
Hello, Sindhu.
As here we have as in neural network, we are having the activation function. Here we have kernel function. Kernel function is a function that corresponds to the inner product of the some expanded feature space. Like in case of neural network, we have segmental activation. The RBF radial basis function will help us to assign the relationship between the input and your output variable. So, and there are different kernel functions available for in support vector machine, that is linear supported linear kernel function, polynomial kernel function. You have different degrees. Then the basis function, which has come from the Gaussian distribution, and that function is most commonly used as a kernel function in case of support vector machine. So the support vector machine terminology is commonly used for the classification problem, and suppose if you have a regression problem, we call them it as a support vector regression. Okay, so support vector regression it come in 1997 by adding the the epsilon insensitive loss function. Then from that onwards, this support vector machine has been extended to the regression column in case of even the time series data also. The general expression of support vector regression is it is same as your neural network expression. Only difference is here you have the kernel function which will be added in terms of I of x. And the coefficients of W and beta are estimated by minimizing the regularized risk function. One thing you have to remember here, the main difference between neural network and your supported regression is, in case of neural network, we have the empirical risk function where difference between actual and output, your actual and estimated output function. But here in this supported regression, along with the empirical risk minimization, general risk minimization also by adding the loss function here. So this is the major difference. And your empirical risk minimization does not lead us to the generalization error, and generalization error will be less in case of support vector regression. So I think it is too technical. So what is your need to understand here
Sir,
is
interrupting, sir. The voice of Om Krishna is interrupting, sir.
yeah, somebody can call him if you have his number and can ask him to mute, or if admin can do the mute, then you can mute him. Okay. The main thing you need to understand here is the so whenever you have the target variable, then we should go for support vector regression. And only input vector should go for the neural network. And this is the structure of the support vector regression, where these dotted lines, our support vector regressions are artificially added variables. It will add the variables artificially, and it will increase the dimension of the model, and then it will do the modeling. So, and the slack zeta I and zeta I star or slack variables, and which will help us to estimate the model by using the kernel tree. Okay, this all I will simply skip. Yes, the main thing is the user-defined parameters, be it support vector regression or your neural network. The user-defined parameters are most important in case of any artificial intelligence models. We have to define the user-defined parameters in such a way that error of the model should be less. And here in case of support vector, we have C, that is the cost. We have lambda, which is a trade-off which controls the smoothness of approximation and accuracy. It will help us to reduce the empirical risk. So C, lambda, and epsilon are user-defined parameters. One should control them in such a way that final error of the model should be less, and we have to try the different combination of hyperparameters, and we have to reduce the error of the model. So for this, there are different algorithms are available. Like no need to like in earlier time we used to do it manually. Nowadays you can directly control your optimize the hyperparameters using different algorithms available, like genetic algorithm, particle sum optimization, and you have Bayesian optimization. Recently, in one of our study, we use Bayesian optimization. You can control your hyperparameters, and then you can give them as an input to the model, and you can build the model. Okay, this is all about the AI-based models, and there are different AI-based models are also available. Random forest and NPs and different models. Those you can try for your data, but whatever model you choose, it should be based on the nature of the data under consideration. And the other time series models, here we have vector autoregressive model. When we have more than two variables which are correlated in nature, we can go for a VAR model. And suppose sometimes what happens, we have some prior information regarding the time series, then you can go for Bayesian time series, prior or posterior information. And sometimes your data is exponential in distribution, then you can go for XPR model. And we have Gauge family of models. Suppose in case of rainfall or the price data, heteroscedastic data, we can have Gauge model. We have ENR for the count time series. We have CART model. We have random forest fuzzy model. Suppose in data is highly uncertain in nature, you can go for fuzzy model. Then you have deep learning, you have granular neural network. So these all model can be explored for data provided it suits your time series. Okay, then we have next class, that is next class of model, that is our hybrid models. As I was saying, sometimes your model, your data has a mixture of both linear pattern as well as a non-linear pattern. Under such condition, your single model will not work. Suppose one data is there and you are applying only a Riemann model and it has non-linear part also, then the model will not work for the non-linear part. Under such condition, and even your neural network also will not work for the linear part. It may work, but ARIMA is better for the linear part. Under such condition, we should go for the hybrid model. The linear part can be handled using the linear model, and non-linear part can be handled using the non-linear model like artificial neural network and support vector machine. And we call this methodology as a hybrid time series model. And under such condition, your hybrid model will work better. Provided it has pattern of both linear as well as non-linear in nature. And for hybrid model also, all the properties should be satisfied. Like it should has a data under consideration should be autocorrelation in nature, and then you build the model. Once you build the model, the main part in this hybrid model building is, as I was saying in ARIMA model, your residual should be normal in nature. But sometimes what happens, you build the model, if the data is highly nonlinear in nature and mixture of linear and nonlinear in nature, your residual sometimes becomes significant. When your residuals become significant, you cannot go for the linear model. So what you will do, if your residual, how you test whether residuals are significant or not? We test the residuals significance by using box PS test. In R is available as box.test. You check the residuals. If residuals are autocorrelated in nature, autocorrelation means your model has some more information left in the data, and that can be modeled using some nonlinear models. So nonlinear, whether it has linearity or non-linearity, you can check it using the BDS test. Okay. So first, what you have to do is you build the ARIMA model, then you go for the residual diagnostic. Residual diagnostic can be done using box PS test. So once the box PS test is significant, then you go for the BDS test, where we check the nonlinearity. Once the data is nonlinear, and here the part n hat, this n hat can be estimated using your machine learning models, artificial neural network or supported regression. Once it is estimated residuals, that estimated residuals again you add them to the your predicted values, and then you compare it with the other models. So this is the methodology of hybrid model. See, I have explained it with the picture here. I have actual series. Then I will fit the ARIMA model here for the linear component, and I will build the ARIMA model. Then I will check the diagnostic checking. I will go for the box PS test. If it is significant, then again I will go for the BDS test. If it is significant, then I will apply the nonlinear component as my time delay neural network part here, and I will combine both the fitted values of both the ARIMA as well as neural network, and I will call them as the hybrid model predicted values. Okay, this is about the hybrid methodology. Suppose if I am using ARIMA model here and time delay neural network, then I will call it as a ARIMA TDNN hybrid methodology. In second methodology, I am using support. I am using support vector regression here. I will call it as ARIMA support vector regression hybrid methodology. And in case of ARIFIMA, I am using ARIMA. I am using ARIFIMA. This is one price data where it was long memory. Then I will call it as ARIFIMA AN hybrid methodology. Then I have ARIMAX model here. I call it as ARIMAX ANS hybrid methodology. Okay, and then we have spatial temporal time series. In case of ARIMA, in the place of ARIMA model, if you take spatial temporal, that is Sturma model, and now you model the spatial temporal basic data with the Sturma model, and then your residual with the ANN model. Then this methodology we call it as spatial temporal time series hybrid methodology, and sometimes your data is highly heterogeneous in nature. You can decompose the data using your wavelet activation function and wavelet transformation, and then you use wavelet activation function in your neural network. Then this methodology is called as wavelet ANN hybrid methodology. And this is all about the hybrid model. If anybody has any doubt till from the basic time series to the hybrid methodology, can ask me. Then explain it with some examples. Anybody has any doubt? If you have any doubt till now, you can ask me. Okay, I assume that you all understood the.
Sir, good morning. I have to ask one question, sir.
Good morning. Ask me, sir.
Sir, can you explain one more time kernel functions that you were explaining? Kernel function.
Yeah. See, kernel function will be used. Kernel function will be used as an activation function, kind of activation function in support vector regression. So it will help us to. It will has assign the weight, and it can be used based on the nature of the data. Sometimes your you have input vector and target vector, and they are linear in nature. You can go for linear kernel function, and if they are quadratic for quadratic kernel function, and if they are radial, they are highly heterogeneous in nature, then you can go for radial basis activation function.
Okay. So, means like basically it is the activation function of neural network. So
Yeah, kind of processing function to estimate your weights are in case of support vector regression.
to establish the relationship between y and x.
Yes, but between your variable and target variable.
Yes, thank you, sir. Thank you.
Yeah, and here I will give some examples. These are all my own published papers. I will explain them with some examples. Characterization prediction of water stress using time series and artificial intelligence models. Here, this is one of my student work. Can you please mute for some more time? I will finish because it is disturbing me again and again. Yeah. Here, this is we developed some drought indices using the rainfall data, and this drought indices like using standard precipitation index (SPI) for third month and 6th month. This 3 months and 6 month SPI we have used as input vector in artificial neural network support vector regression, and we developed this model to predict the drought of the Hyderabad district. So this paper is published in Sustainability. Like here, simply we just employed ANN and support vector regression model in this paper. So next, this is my first AI paper where I have forecasted REC production of support vector regression and TDN. And here, support vector regression has performed better compared to other two models. And here, this is again one of my student work. This is published in Current Science. Modeling and forecasting of quantum production using tuned support vector regression. As I was saying, user-defined parameters. In this paper, we tried different user-defined parameters and we tuned the support vector regression. And this tuned support vector regression has performed better compared to the untuned support vector regression. And this we implemented in the cotton production data. And again, this is a modeling paper where the neural network is used to forecast the drought of the Raichur district, and where the neural network has performed better compared to the your ARIMA model. And this I was saying, Galmits, the data under consideration was count in nature. We implemented NGAS model, ANN model, and support vector regression, and your neural network has performed better compared to the your NGAS model for predicting the Galmits population. And this is again one paper where we forecasted the maize yield of India using ARIMA genetic algorithm. As I was saying, this maximum likelihood estimation can parameters of your ARIMA model, but here we use genetic algorithm approach to estimate the parameters of ARIMA model, and it has proved that ARIMA genetic algorithm has given us better result as compared to your normal ARIMA model. So again, here we develop hybrid time series models. It is a hybrid of ARIMA and support vector regression, given us better result compared to the classical models. And this is, as I was explaining, the intervention model. In this paper, we have seen the impact of COVID-19 pandemic on tomato supply and prices in Hyderabad, where supply has been, we came to know by IMA intervention model that supply has been disturbed, reduced, and the price has been increased during the COVID time period because of the lockdown imposed by government of India. And for this, we have developed artificial intelligence like ANN we use here, and we given the way your impact variable as input layer in the input variable in the input layer. And here again, similarly, again we implemented same model on rice data also. We have seen how whether the rice prices have affected during the COVID-19 lockdown or not. Here we used extreme learning, developed extreme learning model, and extreme learning model has performed better compared to your artificial neural network model for seeing the forecasting under COVID-19 lockdown period. And this is one more paper where we have used evaluate transformation function and neural network, and we developed the hybrid WNN model, and where it has performed better in case of predicting the rainfall data. This is again Arimax ANN, where Arimax ANN SVM has performed better. Here again, this is our Arima supported regression performed better in this model. And here Arimax SVM has performed better. This is ARFIMA paper. We have the mustard price and we forecasted the price, build the model, ARFIMA model, but the residual were significant. ANN for the nonlinear part, and here we call it as ARFIMA ANN hybrid methodology. It has performed better compared to the classical models. Then we have spatial temporal models. I was saying when your data under consideration is has a relation over both space and time. So we have spatial temporal model data. This work for the first time we initiated in the country, and almost published one. We completed we published 6 papers in this. We and our one PhD student submitted PhD in this work, and this model and spatial temporal density model perform better compared to your ARIMA model. And we, as I was saying, different weighting schemes. And here we have developed a fuzzy-based weight matrix, and which is used as an input in the model. And we have developed a two-stage spatial temporal time series model for predicting rice yield of Andhra Pradesh, where we have developed the special weight matrix based on the KNN model. And this matrix is used as the input in the ARIMA model in case of TERMA model. And the proposed model has performed better compared to the classical models. And then we have hybrid spatial temporal model. This is published in Theoretical Applied Climatology. This hybrid spatial temporal model has performed better compared to your ARIMA model. And this is all about different examples. Not only this, there are many papers available by different authors. You can go through those papers and implement your models and choose the right models for which suits your data. And finally, I would like to say no free lunch theorem. It means given two statistical machine learning techniques A and B, there will be as many as situation in which A is worse than B, and there will be as many as situation in which B will be worse than A. If the data under consideration is highly linear in nature and it is satisfying all the properties of ARIMA model, then ARIMA model will performs network model. So we cannot say artificial intelligence models are always better. We should say it is always a data time series model building. It is always a data driven technique. Wherever your nature of the data it satisfies your the model assumptions, that model will perform better. So we cannot say always this model is better. So we call it as a no free lunch theorem. So your model always performance of the model always depends on the nature of the data. So we have to choose the right model for the right data. This is very important part of this talk. Okay, so coming to the conclusion, as I was saying, you have to choose the right model for by seeing the nature of the data. If it is data, first and foremost step is data under for the time series model building. The data under consideration should be autocorrelated in nature. If it is autocorrelated, then you go for the time series, then stationarity, then you build the ARIMA model. We go for the diagnostic checking. If the diagnostic checking is proper, then we end the model there. If it is not proper, then we go for the hybrid model. This is the conclusion of this talk in total. Okay, these are all some suggested readings. You can go for this. There is one paper This is a 2006 paper. If you are beginner in time series, you can go with this paper, 25 years of time series forecasting, which is published in International Journal of Forecasting. This is very basic paper, and like review, they have done the review very nicely. You will understand what is the status of time series, like how under which condition you should go for which model. You know, you can go through this paper, and if you're interested in neural network and hybrid model, you go through this Jang paper 1998, and there is one more three Jang 2000. Yes, one more paper. In 2003 also one more paper they have come, hybrid model. This paper you can go through, you will understand most of the things in neural network and time series. And the whatever the work I have explained here, most of the work that I have implemented using time series, T series package, forecast, F nonlinear, LM test, neural net, ELMR. These are all different packages which I use to implement, and sometimes I use even Python also and MATLAB also for based on the requirement of the work. Yeah, thank you all. And if you have any doubt till now, you can ask me the doubt, and then I will explain. Some 15 minutes is left. I will explain with the demonstration in R. If you have any doubt, please ask me. Anybody has any doubt?
Sir, you can show the coding.
Okay, sir.
Right, sir. Thank you.
Sir, could you please check the chat box once?
The chat box, how to open this? Yeah. There is chat box. I'm unable to open it.
I think it is a not a quantitative data. It is a scale data. I think she is saying.
No, I'm unable to see the chat box here. Where is the chat box?
Even if I
No,
want
the
to
question is,
Right side, the
could you please
corner,
suggest which are the
bottom
best
corner.
suited statistical methods and models to measure and compare the manager's views, perception towards earlier technologies versus future technologies to measure the technological changes and other associated changes. So it is only a Likert. So she is asking which methodology is best.
Yeah, 1 minute, sir. I'm unable to read.
This was posted by Durga.
1 minute, sir. Can anybody?
Right side corner, bottom corner.
Yes,
You have
now.
a chart. You can open that.
Could you please suggest which are the best suited statistical methods and models to compare the HR manager's views perception towards the earlier technologies versus future technologies? Yeah, you can go for the non-parametric test, ma'am, and you can, as sir was saying, you can go for the Likert scales, and then this can be if it is if it is following proper scale, you can go for the chi-square test of where you can estimate the where you can quantify the relationship between the data. So better is non-parametric test we can use for. We can discuss in the later stage. If you have any doubt regarding this, you message me. I will help you, ma'am. So this is not related to this is a qualitative data, not time series. So you can message me. I will help you with this. Could you please suggest which are the best suited statistical models and models to measure the compare manager? This is again this is a qualitative only. Again, chi-square test will help for this, and we can discuss this later. Okay. So now I will share my R screen. I have shared the R code also. If anybody interested simultaneously, they can also do this.
All the files were shared to all the registered participants, sir. I think
Okay,
they can open it. I think it may be in your mails.
Yes, sir. Yes, sir. Okay. Yeah, when I click on the file, so it is a R file. So this is the code I have written before. See, I have the data here. I will explain the data also here. And this is the rainfall data from some Kerala, some random district data I have taken. The first code is RM. RM means whenever you start the new session with the R, you have to remove the earlier scripts which you have run in the executed in the R. So here I will run this, though the history will be cleared here. And if you want to clear this console window, then you can press Ctrl L and this also will be cleared. And to do the any kind of analysis, we need to install the libraries every time. So for this practical classes, we need these many libraries. We need forecast, we need E1071 for supported regression, we need T series, we need ggplot2, tidy for data manipulation, we need F nonlinear for BDS test, we need LM test for checking the coefficient. Okay, so this again I will clear it. So what you can do is, if your data is stored in the same file, then you go to the session and then start set working directory, go to the source file location. So you will set the working directory. Then you can simply click on this, but this name should be same in the you run this code. My data is imported. I can see here G. If you type G here, this is my data, but the screen will become full. So what you can do is you can just type a head of G. So first 6 observations will be visible. So this is my rainfall data, and I want to see the dimension of data. You type 1 minute, sir. I have one call. I just talk for 1 minute. हेलो, मेरा एक क्लास चल रहा है, मैं आपको बोला था ना, और एक आधा घंटा है, एक 15 मिनट में खत्म हो जाएगा. हाँ 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 हाँ, उसको कट करेंगे. हाँ, मैं उसके लिए मैं आ रहा हूँ 10 मिनट का टाइम. हाँ, नहीं, आप जेसीबी लेके आने से अच्छा है, क्योंकि वो व्हीकल भी ओके. आ जाऊंगा मैं आ जाऊंगा. If you want to see the dimension of the data, then you type DIMG. So this data has 1428 observations, right? So as I was saying, for any time series, we need to see whether the data is autocorrelated or not. So box dot test function is used to see whether the data under consideration autocorrelation or not. Here if we box dot test G of rainfall, G is my name of the data. I will type it here again, box dot test. G is my data, and if you press here this dollar, then rainfall will come, and enter. Yes, my data, the probability value is less than 2.2 e to the power minus 16. It means it is less than 0.001. So my data under consideration is autocorrelation in nature. So we can go for the further modeling. So can anybody tell what is next step? So data is autocorrelated. What is the next step? Next is we'll plot the data. So here I have the plotting file, that is RF1, and this is how my data looks. The data is highly non-linear in nature. So it is so what we do is we go for the BDS test. And the BDS test, what it will do is it will divide the data into different parts, and it will see the non-linearity. And most of the parts you see here, 3 parts, most of the parts they are non-linear in nature because probability value is less than 0.001. Okay, so what I will do, as I was saying, we'll divide the data into 2 parts, that is training set and testing set. The first 1416 observation I will use for the model building, and remaining observation I will use for the model testing validation purpose. Okay. Again, both the parts, like this validation, training and testing part, I will check whether they are autocorrelated or not. Here the data under consideration is again autocorrelated in nature. Then I will use the ACF and PACF. You can see here the data under consideration is seasonal in nature. So for this model, since it is a rainfall data, monthly data, it is seasonal in nature. You can go for the deseasonalization of series, or we can build the Sarima model for this. But for practical purpose, to finish the class early, I have not done the deseasonalization of this. you can, if somebody is interested, you can go for the Sarima model for this. Okay. So there is a no need to choose a model manually. There is a function called auto.arima in the forecasting package. So if you type auto.arima and the name of the data A1, then your model will be built. My model has built now, and it has given me the observation. This is my model 412. So the original series was not stationary. It has made the data into stationary by first differencing, and it has taken 4 input lags and 4 autoregressive orders and 2 moving average orders. So this is my orders, but it will not give whether they are significant or not. For that, we have the function COEF test in case of in the LM test package. And if you type this, the most of the parameters are significant in nature. Then, as I was saying, once the model is built, we have to see whether RMS is. So RMS is 164 here for training. As I was saying, diagnostic checking, whether the model is a proper fit or not, we have to see the diagnostic checking boxes or test and of residuals. Here I have given M1 dollar residuals. So here if you see, my residuals are significant. So it means ARIMA is not a proper model for this. So my residuals are significant. Once my residuals are significant, then I should go check whether they are linear or non-linear. Once they are non-linear by BDS test, then we can go for the hybrid model for this, right? So here ARIMA model is not a proper model. So this function, then we can take out the fitted values, and then write.csv can be used to take out the fitted values outside of your in your desktop. You can use that function. Then you can forecast. I am forecasting here for the last 12 months, and if you type here F1, these are all my forecast values, right? 22, 75, 166. So this also I can write them in the ARIMA fitted CSV. The file will be saved in the name of ARIMA fitted CSV. So if values. So this is the file which I created. This file you can open it in your, you can save it, and it will be saved in your working directory, right? So the next is, once it is forecasted, then I will compute the forecasted, sorry, F1, yeah, forecasted error also. So that can be computed using this formula RMSE1. The forecasted error is 222. Okay, this also can be saved. So once this ARIMA is built, now what I will do is I will build the neural network model here. So here I am taking 6 input lags and 10 hidden nodes. This you can change, and there are some functions where it will build it itself. If you give just NNETR into AN, then also it will build. Okay. So, and this is, I call it, you can try with a different combination of layers, and you can see the performance of the model every time. So my model has built here M2, and I will check the accuracy. There it was 260 something. I will type here accuracy of M1 is 164, but accuracy by neural network is 107. So my error has reduced drastically. So this data under consideration non-linear in nature. So we can build ANN, we can consider ANN as a suitable model for this, right? So once again you build the model, then you go for the fitted values, then you write the CSV, you can save the model, and you can calculate the forecasted error. Forecasted error is 264 here, right? And you can save it here. And as I was saying, without giving the hyperparameters also, we can build the model directly by automatically by software, the R package. It will give the M3. If you give the just data name, it will give the hyperparameters itself. Okay. Okay. So my accuracy is 49. So from 266 to the accuracy has come down to, the error has come down to 49. So this result you can, if you want to visualize, you can see it, and you can calculate the RMS again. My RMS is 3, and if you, for forecasted RMS is 197. And if you see the residual diagnostics, my residuals are significant. So I can say here, ANN model has non-significant residuals, and it is a better model as compared to my ARIMA model, right? And this result also I can save it. And if you want to see support vector regression, again you can see the support vector regression here. As I was saying, I have divided the data, and in support vector regression we need to give target variable. Target variable, what I have done here is, for today's rainfall data, I have given tomorrow's rainfall data as a target variable. Like that, I have made them into training and target variable, input variable and target variable for training set as well as testing set. Okay. So you can see, you can build the model. This is all the model parameters. You see the summary. This is my, as I was saying, support vector regression. The model has support vector regression model has given 1416 artificial variables to it, and it has increased the dimension and it has done the modeling. So you can calculate the fitted values. RMS is 4 and my RMS is 188. Okay, it is not a good model as compared to ANN model. So, and residuals are also significant even for the support vector regression. It means you have to build the model properly by choosing different hyperparameters. Okay. So we'll get the predicted values here. And as I was saying, DM dipole Merino test, if you want to see the significant performance of the different models, you can see here the model 1 and model 2, their probability value is 0.016. It means ANN has a significant performance over the ARIMA model. And here also again ANN has significant over your support vector regression also. So next is we'll go for the hybrid model building. Hybrid model, the step is once the residuals are significant, then we should go for the box BDS test. First I am seeing the residuals here, and my residuals are, earlier we checked whether residuals are significant, then even they are non-linear also. Then we build the model using the neural network. Here my N1, which is N1 is a model name which I am building upon the residuals. It is taking some time because the neural network is iteration process. It will take some time to, yes, the model is fitting has been done. And what I am doing, this fitted values I am combining with the ARIMA fitted values, and I am seeing the hybrid. Like hybrid means the fitting combining of your ANN residual fitteds and ARIMA fitted values. I am seeing the performance. See, from 46 to it has given me 38. It means my hybrid model has performed better as compared to your classical models. So if you want to see further accuracies, you can see here. So ARIMA has given 164, ANN has given 107, but your hybrid model has given you 38. Okay, it means my ANN model has performed, hybrid model has performed better as compared to ARIMA model when it has mixture of both linear as well as non-linear pattern in it. Okay, finally, suppose this is one data. If you want to, I don't know whether yes, I have the data. If we want to plot whatever we have done here, yes, my fitted plot will look like this is for the ARIMA intervention. As I was saying that in COVID-19 we have seen the effect of that COVID-19 lockdown on the tomato. This is pre-lockdown period and this is lockdown period. So this is a clear difference that it has the impact. So this is all about this practical class, and if anybody has any doubt in this, you can ask me. This is all about my practical demonstration. I think within 1.5 hours it is very difficult, and whatever possible I try. And further, if anybody is interested and if you have any doubt, you can take my contact details and you can ask me if you have any doubt in the future.
Dear participants, any questions? Any doubts? Sir, I think though your session is very elaborative and more informative, I think we have already shared your presentation and all codes, sir, to each and every registered participants. And clearly, it is wonderful session, especially for the youngsters who are working on forecasting, especially in artificial neural network and machine learning, and we have discussed models also and showed the coding and everything. And with this, I think the participants are going to be benefited with your lecture. And anyone wants to further any queries or anything, you can contact us, the organizers. They can provide our Rathod sir number and all. and he's a very dynamic researcher in the Indian Institute of Rice Research. It's a very, very famous institution in ICR. So with this few remarks, I once again thank you, Santosh Rathod sir, for accepting our request and giving your elaborate and informative lecture on today's workshop in the first session. And we have one more last session from 6:30 onwards, 6:30 to 8, by our another friend Sushil Kumar Sarkar, Dr. Sushil Kumar Sarkar, who is going to talk about the multivariate techniques. So with these few remarks, I once again thank all the participants for your nice participation. But I am requesting once again, few people are disturbing the speaker. So I am requesting once again, please mute your audio when you are listening, so that the speaker can concentrate and give his best. So with these few remarks, I once again thank my teacher, who is all the time here, Dr. L. Venkateswara Garu, and the faculty who are in the workshop. Thank you once again. Thank you all. Thank you.
Sir, thank you very much for giving me an opportunity to speak here. Thank you, sir. I enjoyed taking class here. And someone is asking, like, can you suggest applied textbook for time series? But there are many textbooks are available. The box Jenkins book is available on online. So if I have the soft copy of both the box Jenkins and other book. If anybody wants, they can message me. I share my email ID to the book. Yeah, thank you very much, sir. Thank you.
Okay, sir. Thank you. Thank you very much. Thank you. With this, we can wind up and we'll meet at 6:30 today with the last session. Thank you, sir. Thank you.